Today I'm going to talk about some keywords about my research. First is about the beamforming and the microphone arrays. In acoustics, beamforming is a signal processing technique used in various fields and to focus the transmission and reception of a signal in a certain direction. It can combine signals from multiple sources and then strengthen the signal in the desired direction while suppressing it in other directions. In the other way, in sonar systems, beamforming is employed to actually to uh, accurately detect and track the targets by steering the transmitted or received beam towards a desired direction. So from the description above, from this perspective, we have two main branches of acoustic beamforming. First is about the signal extraction, and second is about the source localization. So in our SLAM research today, I think the latter one, the addressing source localization, is more related to our project. This is a figure shows how the beamforming works. And next, I'm going to talk about the microphone arrays. The microphone arrays help us to achieve the DOA, this direction of arrival. And there are many ways to get the DOA, and one method of DOA is about a method called the classic GCC PHAT, the generalized cross correlation phase transform, and the method is listed below. This is a signal. This is the signal model is shown like in this figure, uh, which the condition is a far-field plane wave with a binary array, and this is the correlation formula. Uh, when the two signals are correlated by a delay called tau. In tau, it's a time is used to describe a time delay, and the value shows to be infinite. While when the time is not related, the calculus shows start to be zero. And by implementing the formula listed above, we can know the time difference of arrival about 2 microphones. And secondly, we know the geometry of the microphone. So in our project, it's a circular microphone. With 3 or more microphones, we can solve the DOA by using the trigonometry to solve several formulas. And we have 6 microphones, so we can optimize the result by using the least square method. Uh, so simply speaking, the microphone array is just refers to an arrangement of microphones. There are several popular microphone arrays which are first linear in a line, circular like a circle, and spherical. And so in our project, and also in consumer product, there are two common types of arrays used. First is like used in is a binary array, which is used like in a cell phone, in a smartphone. And the second is like a 6 microphone array that's arranged in a circular way, which is used in our project today. And I'm now going to talk about some very simple definitions of some acoustic keywords. First is about the supersonic. Supersonic just refers to as a speed that travel faster than sound of the speed. It's about like faster than 343 meters per second. And ultrasound means that travels in a frequency higher than the upper limit of human hearing. It's about like a higher than 20,000 hertz. Next is about subsonic. Subsonic has about like two different meanings. First is like just opposite to supersonic, which is travels less than 343 meters per second, and next is about that lower than the audible range of humans ear limit is about like below 20 hertz. There are some high frequency hardware used, uh, like the radio, like a smartphone, like uh, in medical conditions about like MRI, ultrasound, and CT as well. Uh, Low frequency hardware is also used like in seismic monitoring equipment and submarine communication systems. The next is about the PID control. PID control is widely used in industry and scientific research. We also use a programmable logic controller, a PLC, to carry out the PID algorithm. Uh, a a PLC is not too expensive. We can buy it from retailers or e-commerce platforms. It's about like 500 yuan. We can also carry out the full algorithm on STM32. This is what a programmable logic controller looks like. Next, I'm going to talk about audio isolator. It's just a small device to break the electrical connections between the audio equipment from the recorder, such as like our PC, to prevent noise we do not want. So it uses some like electronic devices, some like the capacitors, like inducers, to filter out the noise, which is also available on Taobao. It costs about 50 yuan. And the final things I'm going to talk about is about the sensor fusion, which is really important in the work of SLAM. It just means combining data from multiple sensors. So in our situation, uh, we are doing the heterogeneous sensor fusion because we have different sensors like the lidar and about the microphone arrays, unlike the same kinds of sensors. And there are about 3-layer fusion structures which are used in sensor fusion. And such as we are using the different types of sensors, we can only implement the feature layer fusion and the data layer fusion, which has a slightly different. We're also going to use the centralized type of hardware architecture of information fusion because our device is really small, so we don't need to use like distributed and hybrid version like something like in a very modern car. Um, I think the most important part is about the algorithm or the method of information fusion. So there are so many uh, algorithms and optimization methods used in the SLAM. But for our project today, we are going to use the traditional and the most reliable and simplest way in the multi-sensor fusion, which is could be classified into the estimation methods such as the Kalman filtering. Also, we can do the artificial intelligence and like the neural net CNN, the neural network in our further research, which may get may we can get we can obtain better results, but may require plenty calculating resources such as like the GPU or something. So that's the references. So thanks for watching today.